Hey guys, today we're going to look at a few more things about basic functions so that we're ready to move into looking at specific types of functions for the rest of what's in this unit. But today we're going to look at how to describe function symmetry, how to evaluate functions, and how to find the average rate of change for functions. So by the end of this lesson, you should be able to describe the symmetry of functions, evaluate a function for a specific value, and determine the average rate of change for a particular interval. And I'm using a pen instead of my normal stylus, so if all the clicking is driving you crazy, I apologize. Maybe it won't pick up as loudly as I think it might. So let's get into this. So function symmetry is very similar to like symmetry that you would have learned about in elementary school. If you remember in elementary school learning about how if you took a butterfly, pretend like I can draw, and you drew a line down the center of it, it would create two sides that were exactly the same. And that means that that butterfly is symmetrical or has a line of symmetry at that point. Function symmetry is kind of like that, but there's two specific types of function symmetry. Your function can either be an even function, meaning it's symmetrical about the y-axis, which means you could fold it across the y, and it would create two mirror image sides of each other. And so I've got an example of that right here, so we can look at that. This function in the middle is an even function. And so if you were to fold it along the y-axis here, you can see how what's in quadrant 1 would mirror into quadrant 2. They would overlap. What's in quadrant 3 down here could mirror across to quadrant 4. They would overlap. So that's what you're looking for even symmetry, where what's in quadrant 1 flips or reflects into quadrant 2. What's in quadrant 3 could reflect into quadrant 4. That creates even symmetry. Odd symmetry means it's symmetrical about the origin, which means you can fold it across both axes to create it. Now, this first one that says odd function is the one that does that. And when I say fold it across both, I mean you can take what's up here, you could reflect it down and then reflect it across, and it would be mirrored here. But typically we don't think of it that way. Typically we think about odd functions being mirrored across the origin, and you just look for a rotational symmetry across your origin here. So what's in the top quadrant should rotate and be recreated at a 180 in the third quadrant. What's in quadrant 2 should rotate and be recreated as a 180 in quadrant 4. So it's rotational symmetry across the origin. And then some functions don't have any symmetry at all, and that means that you're not going to be able to flip them across the x or rotate them to recreate them. So what's up here does not mirror itself down here or over here. So it's not symmetrical about the y-axis or about the origin. Now, there is a line of symmetry in that, and when we do quadratic functions and we look at parabolas, the shape of a parabola, there is a line of symmetry that exists right here, but that line of symmetry is not functional symmetry. It's just a line of symmetry or an axis of symmetry in a parabola. So we don't call that even or odd. It still has, it's neither even nor odd. So you determine function symmetry simply by graphing the function and then looking at it to tell if it's symmetrical or not. All right. So here's an example of two different functions. So this function that's right here is not this graph that's over here. This is a completely different function. So I've got two examples on this one slide. We're going to start by looking at the function that we have here in Desmos. So I'm going to move this over maybe. Maybe not. Just kidding. Yo, I'm dying here. Move. Okay, just kidding. Craziness. All right, so I'm going to graph f of x equals Maybe I am. Maybe I'm not. F of x equals x to the third plus x squared. Okay, there's my function. So now if I want to decide if this function is symmetrical or not, I'm going to look at it, and I want to see if I see that it mirrors itself left or right. Does it mirror itself across the origin, or does it not create a mirror image at all? And sometimes it's helpful to zoom in a little bit so you're looking at it real closely to be able to tell this. So when I look at it, if I look for even symmetry first, that means I'm going to look left or right. And what I have in the first quadrant should become the same thing in the second quadrant, but reflected. What I have in the third should become what's in the fourth quadrant, but reflected. But if you look at this, it doesn't do that. On the second quadrant over here, we don't have anything that looks like this flipped over. It would be like that, and it's not. So this is definitely not even symmetry. So then I'm going to look for odd symmetry. And so to look for odd, we're going to look across the origin to see if what I have in quadrant 1 rotates into quadrant 3. And if what I have in quadrant 2 rotates and recreates in quadrant 4. So that means that what I have here should also exist down here on this side. Now this looks very similar. There's a line this way, and there is a line here. The question is it a perfect recreation of it? So if you notice, this line starts in the top and works itself down to the origin. This line starts at the bottom and works its way up, but not to the origin. So this is not a rotation into this quadrant because it's not exactly the same. At the same time, you can see that in this and how it doesn't recreate itself down here because you don't have that bump at all. So this actually has neither odd nor even symmetry or no symmetry at all. So we would call this neither or neither, however you want to pronounce it. I'm not picky. Tomato, tomato. So neither. Now the next one, the one that's already graphed for us, again, we want to treat it the same way. We're going to look left or right first to see if there's symmetry there. And so when I look at that, I've got this bump here that is recreated on this side in exactly the same place. It looks like if I folded through the middle here, what I have would overlap perfectly on top of itself. So that means this has symmetry. Specifically because it's left or right, it's even symmetry. So that would be an even function. All right, moving along. So here we have another one that we've got to put in Desmos to look at. So I'm going to grab Desmos here. Type in f of x equals x plus 1 squared. Okay, there's my function. It is parabola shaped. Here is my y-axis. So to check for even symmetry, I've got to see if what I have in quadrant 1 reflects or mirrors itself into quadrant 2, reflects itself into quadrant 2. And it's the same type of line, but it is not a perfect reflection. And the reason I know that is because I have a point down here on the axis that I don't have over here. And so this is not even symmetry. I also know that it's not odd symmetry because I don't see anything reflected across the origin on either side. So not odd either. This is another example of one that has no symmetry. And there are a lot of functions that have none. So don't be surprised if you get that. So this is also neither odd nor even. Now this one, if we look side to side, we notice that it's not mirroring itself that way. But if we look across the origin, what I have up here is the same as what I have down here. What I have on this end is the same as what I have up there. This is symmetry about the origin. This is an odd function. So because it flips this way. And nothing in quadrant 2, so still nothing in quadrant 4. It is odd. All right, rolling along. Take a second, pause the video, and try these two and see if you can figure out if they are odd, even, or neither. And come back and see if you're correct. All right, hopefully you worked those out and you ended up with odd for the first one and then neither for the second one. The reason that first one is odd, when you graph it, you end up with something that looks kind of like that, but it's perfectly aligned with the origin, which what I just drew is not, but definitely had odd symmetry. It was not left or right. It was across the origin there. And then this one does not have symmetry because what you have on one side is not the same as what you have on the other from either direction. Okay, so symmetry is done. Now we're going to look at evaluating functions. And this is a lot like evaluating expressions, but some of this can be done in Desmos, which makes this a little bit easier. So functions are usually written in function notation, which means they take the y equals out and they replace it with like f of x or some other number or letter like that. Sometimes they'll put g of x, sometimes they'll put h of x, random stuff. In that notation, the independent variable, the one in parentheses, can be replaced with a number to make it represent a specific value. That means you should be evaluating the function at that number. So if you're going to do that, all you got to do is substitute value in the parentheses, in for the x in the problem, and solve it. You also can just type it into Desmos. Just type the function in, and then type the function value in, and then it'll automatically tell you what your solution is. So things you want to pick up from this, when you're evaluating functions, if they tell you f of a number, that number is an x value. If they tell you f of x equals a number, that number is a y value, because f of x means the same thing as y. So when it says f of x equals that number, it's saying y equals that number. So the number in the parentheses represents an x. The number that your function equals represents a y. That's the only part of this that's even remotely difficult, is mixing up what's in parentheses as is it an x or is it a y. Because the rest of it is pretty simple. So let's look at how this works. So here we've got a table, and they want us to evaluate the table for these 4 different situations here. So we're finding f at 0, we're finding f of x equals 7, we're finding f of 8, and finding the value of the function when x equals -3. So to be able to do this correctly, you've got to know what exactly they're asking you to look for. So for A, when they say find f at 0, they want us to find the place where the x is 0. So if I look at my function, x is 0 right here. And so the value of the function right there is -1. Now in this next one, when they ask us to find where f of x equals 7, find the x, they're talking about where does the y equal 7, because f of x means the same thing as y. So we're trying to find the place where y equals 7. If I look at this, y is 7 here, and y is 7 right here. So there are actually 2 values for this that work, -2 and 2. The next one asks us to find find f of 8. Again, because that number is in parentheses, that's going to be an x. So I'm going to go to my x and find where x is 8. Right here at 17. And then the last one says, find the value of the function x equals -3. If it tells you x equals -3, then obviously that's an x, and we're going to find where that is along the x-axis. So x equals -3 right here. The value of the function right there is 17. So you're basically just finding the other half of the pair. You just have to know which half you are looking for and which half you're being told. Otherwise, you might get all that mixed up if there's same numbers in 2 spots. All right. Then you could also see this on a graph. Applies the same way, but in a graph, we know that the x's are the ones that are done left to right, and the y's are the ones that are up and down. Uh-oh. I'm not sure what just happened. So left to right, up and down. So when they tell me to find f of 3, that means I got to find where my x is 3. So I'm going to go on my graph, look across here to where my x is 3. Here's where my line is. So this point right here represents f of 3. The value of that point is 3, 1. So that function's value at 3 is 1. I'm just giving the other half of that point. Now B says if f of x equals 2, find x. Remember, f of x is the same thing as y. So if y equals 2, what is x going to be? So I'm going to go along my y-axis this time, find the value at 2, and here's where my line is at. So this point is going to be my solution for that. So that point is 0, 2. They wanted me to find x, so 0. Next one asks for f at negative 8. We know that if it's in the parentheses, it's an x. So I'm going to go across my x to negative 8. My graph exists up here at negative 8, 5. So the value of my function at negative 8 is 5. And then the last one asks for the value of the function at x equals negative 5. Well, obviously that's an x. So we go on the x to negative 5. The function is right here at negative 5, 4. So the value of my function at negative 5 is 4. Pay attention to whether they're giving you an x or a y. That's going to be the thing that makes the difference here for you. All right, rolling along. So these ask us to use equations to evaluate. And this is actually really easy because Desmos will do most of the work on these for you. So to be able to evaluate, the easiest thing to do is to come up with a graph of it and then to find the value wherever they're asking for. So if I go and I put in f of x equals absolute value, and I use this little a right here for that, by the way, this little thing right here. X minus 7. Oops. Plus 2. Okay, there's my function. Now, if I want to find the value at negative 2, I just zoomed some kind of crazy. I could go and find on my function where it would be when the x is negative 2. Like I could just work from here and I could work my way up using some of those points. And I could find its value at 11 like that. That's absolutely a reasonable thing to do. You also, though, can just type in Desmos f at negative 2. And it's going to tell you exactly what its value is, just like that. So at f of negative 2, the value of the function is 11. Now, if you've got one like this next one, sorry, I got distracted, and we're doing h of x equals negative 2x plus 4, and they tell us what h of x equals, that one's going to graph a little bit differently. Be very similar, but a little different. So let's get that in there. H of x equals negative 2x plus 4. So there's my graph. Again, I could go and find where the y is 4 because I know h of x equals means the same thing as y equals 4. And I could go find that point and find the x value from it, kind of like what we did on the ones that gave us a graph. But you also can type in down here h of x equals 4. And it's not going to tell you a point like the last one did, but it's going to give you a line. And if you can find that point of intersection, you'll know the point that would be the solution here. So I can see where my two lines cross at 0, 4. So the x value there that they asked for is 0. So find x, x would equal 0. So this next one's done the same way. they give us g of x equals 2x minus 7. And look, the letter you use doesn't matter as long as you're consistent. So even though it says g of x, I could leave h of x in there and do 2x minus 7. And then say h of x equals 7 this time. And I'm still going to get those two lines. They're going to cross. Now, if you use two different letters, you're going to get things that won't work. Because what Desmos is doing here is it's saying, okay, if this is the h function and I know this about it, then those two together create this. So if you name something the h function and then you put like a g in for this, it won't know to relate this to that. So we're going to go with the same letters with that. And I get the 0.77. So they ask for the x value from that point is the 7. All right, and then this last one, j of x equals 3 to the x. And they want us to find j of 3. So, j of x equals, forgot what it said, 3 to the x power. So to do an exponent like that, 3, and then you press this A, B button right here, and that's going to create our exponent, and then I can just put an x in that space. Like that, and it creates this exponential function for me. And they want the value of j at 3. Now again, I could do what I did on that other one. I could go and find points until I hit 3. Then I'll be able to see the value of it is 27. But I also can do just j of 3, and it'll automatically give me that value at 27. So it doesn't really matter which way you do that. Sometimes you get some really big numbers, though, and trying to go up and down your graph would take you 100 years. So just calculating it in Desmos like that is going to be an easier option for you. All right. Look at a couple more together and let you try a few. So if you see this in a word problem, usually function word problems are going to give you an equation. Like this one says, the function f of x equals 1.5 times 2 to the x. Describes the growth of a certain bacteria after x number of days. Find the amount of bacteria after 3 days. So they're usually going to give you a function. They're going to give you some value. Your first goal has to be to decide if the value they give you is an x or a y. So when they ask me to find the amount after 3 days, and I've got to decide is that x or y, well, over here it tells me x is the number of days. So 3 days is going to be an x, which means I'm going to evaluate this function for f at 3. And then you can do that in Desmos. You could also just substitute a 3 in for x up there and solve that. Either way is going to get you the same answer. And so if you evaluate this function at f of 3, you end up with 12. So there would be 12 bacteria in this after 3 days. Now the next one says the function f of x equals 75 plus 15x models the likes on a photo, the number of likes a photo receives based on x hashtags. How many likes will a photo receive if it has 6 hashtags? So there's my function. Here's what I know. Again, I've got to decide is that an x or a y. So since my function says x hashtags, I know 6 hashtags has to be an x. So I'm going to evaluate this function at f of 6. And if I do that, I can put that in Desmos, or I could substitute 6 in place of x and calculate that. And I would end up with 165 likes on that photo. So don't let the word problems strip you out. Sometimes they're going to have some really complicated sounding stuff in them. But for the most part, it's just going to be a matter of pulling the equation and finding what they tell you about it, and then substituting those values in place. All right, so let's let y'all try a few. Take just a minute and look at this slide, and I want you to evaluate the first one with the equation, and then find the answer to the second ones using that graph there. And then once you've done that for all of it, come back and see if you were correct. All right, take a look at these and see if you got the same thing that I got. So when I evaluated the first one, I got 8. And then when I checked these next ones, f at 6 existed right here. So the only point on the line was here at 2. Here they asked me to look at where f of x equaled 1. That would be anywhere along the y that had a value at 1. So this point at 4, and also, and most people forgot this one, this point down here at about 9.3, and I'm kind of estimating that, but it's pretty close to 9.25, 9.3, something along those lines. A little bit more than 9, but not as much as 10. So if there's 2, you got to give both. Make sure you look for situations like that. All right, and that's all there is to evaluating functions. So now we're going to look at calculating average rate of change. So average rate of change is pretty simple. The average rate of change really is the same thing as calculating rate of change for a linear function. It just tells us how much the function increases or decreases over time. So just like we do in a linear function, we find average rate of change using slope. So there are 2 ways we could find slope. You can find slope doing rise over run. So if you're given a graph, that's your option. Or you can find slope using the slope formula, which is what we're going to use most of the time with this. So slope formula, remember, is y minus y over x minus x. So average rate of change is used when functions are not linear. So you're going to end up, when you did slope with a linear function, it didn't really matter what points you picked. You just picked 2 stop sign points, and you found the slope, and no matter what points you picked, you get the same answer. But with average rate of change, since the functions are not linear, you have to be very specific about what points you use. You have to use the point at the beginning of the interval and at the end of the interval. Cannot use just random in-between points. You're going to get a different answer if you do that. So let's do some examples of this. So here they've asked us to find the average rate of change over the interval from 0 to 9. Now these numbers here in that interval tell me the x values of the points I'm supposed to use. So I've got to find the point where the x is 0 and find the point where the x is 9. And they actually show us those on here, but I've got a point here at 0 and I have a point up here at 9. Now, I have 2 options here. I can use them as points, and I can do slope formula with that. And if I do that as my option, then I'm going to do the y's on top, so 3 minus negative 7, and 9 minus 0. And I'm just going to calculate that. You can use your calculator, you can do the top and then the bottom, and then divide that if you're doing this by hand. But either way it goes with this one, if you calculate that one, you end up with 10 over 9. That is our average rate of change. Now, if you don't want to do that with the slope formula, but you have a graph of it that's reasonable to count, you can do rise over run. So I could go from this point and rise until I'm even with the upper point, and then run until I'm even with it, and then count that value. So if I did that, I would be going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps up. And then I would be running 1, 2, 3, 4, 5, 6, 7, 8, 9 steps to the right. And I would do the same thing, 10 over 9, to get my average rate of change. So even though you have all this swirly business here, the average rate of change is found using the beginning interval and the end point of the interval, and then looking at how that change occurs. So slope formula or rise over run, if you're given a graph of it. Sometimes if you've got a graph of it, it's not going to be very easy to count, so you need to be prepared for that and be ready to use slope formula if it's complicated. All right, let's look at one where they ask us for average rate of change from a function that is, trying to pinch and zoom, I'm failing, not graphed for us already. So we're going to graph this in Desmos so that I can get some points that I can use, because to do this, I've got to know 2 points. So I'm going to graph g of x equals x to the third minus 9x. So g of x kidding. Equals x to the third minus 9x. So there's my function. And what they want me to look at is the interval from 1 to 6. Now, to find the value of my function at 1, it exists right down here. At -8, it looks like. But then to go and find it back at 6, I'd have to go way up here. It might take me forever to get there. So a better option with this is if you've got a function here, you can use this little cog button. Just click on that little cog button, and it's going to bring up these options. So if I click on that cog, that settings wheel, whatever you want to call it, it brings up the option to do 3 things. You can either create a table of values, you can duplicate the function you've got, or you can delete the function altogether. For me, a table of values would help because then I'll know exactly the 2 numbers that I need, and I can use those 2 numbers to calculate my average rate of change. So here's my table. Now, I've got to have the values at 1 and at 6, and the way I know that is because that's what my interval says. So I'm going to look on my table. It gives me the value at 1 is -8. So I know I have a point at 1, -8. But to get my point at 6, I don't see that in the table. So I'm just going to add a line. Just tap right under the bottom there. Maybe. There we go. And I'm going to type a 6 in that space. And it's going to tell me that point. So the point on the function at 6 is 162. So 6 and 162. And so those are going to be the points that I use to calculate my average rate of change. I would not try to rise and run that. That would be kind of insane. But I can use those points to calculate this with slope formula. So subtraction, subtraction. And on top, I'll do my y's. So 162 minus -8. 6 minus 1. And if I calculate that, so I put that in my calculator with a fraction bar, or I do 162 minus -8, and then 6 minus 1, and then divide that. Either way, I'm going to get 34. So the average rate of change for this function on that interval is 34. Oh, that copied that. That was not intentional. I was trying to move it, y'all. We'll just leave it. Okay, whatever. All right, let's do one more on a graph together and then let y'all try a few of these. So here we're going to look at it from -8 to -2. And I know that because that's what my interval tells me. So again, the interval tells me where on the x to look. So on the x at -8, my point is down here. And that's at -8, -8. At -2, my point is up here at -2, +3. And so I can use those to calculate slope using slope formula. Or if I rather, because I've got a graph here that's reasonable to count, I could just rise and then run to get my slope for this one. So let's say I wanted to rise and run instead. I would go from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So up 11. And then I would run 1, 2, 3, 4, 5, 6 over 6. And so my slope for this would be 11 over 6, or my average rate of change would be 11 over 6. But again, if you prefer slope formula, you can do that too. Subtraction, subtraction. Put your y's on top. 3 minus -8. X is on the bottom. -2 minus -8. And we're going to get exactly the same thing. 11 over 6. So either way you want to do that, it does not matter to me. But know how to do both because different situations will call for different things for you to do. All right. Take a minute and see if you can come up with your average rate of change for this one. And then take a look at the next two that give multiple choice answers and see if you can come up with correct answers for those as well. Those are going to require you to calculate rate of change for a couple of different intervals to make a comparison. So it may take you a few minutes to work through those, but take the time to do it so you can see which one's going to be an average rate of change according to what they are looking for there. Once you've done all three of those, so don't do the ones that say test prep or whatever yet. Just do those three and then come back and see if you're right, and then we'll get into the test prep questions. All right, look back at this one. You should have gotten an average rate of change of 1. And if you did not get that, take a look and see what I did that was different from what you did. Because there's a, you should have gotten the points negative 214 and 319, and then use those with your slope formula to calculate that. But if you missed some part of it, look at maybe how you set that up. You should have been able to come up with 5 over 5, which becomes 1. The next one asks you to see when the temperature increased faster. That means you had to compare the rates of increase for both of those intervals there. So from 6 a.m. to 9 a.m., I used those points, calculated slope. And then from 9 to 1, I used these points to calculate slope. And I found that the first two had a faster slope than the second two. So A was the correct answer there. And then in this one, they wanted to know when you had an average rate of change of 0. And so you could calculate rate of change for all of your points there and find that C is the one that has a rate of change of 0. But I also want to show you another way you can kind of look at this. Points that have an average rate of change of 0 are going to be points that don't rise or fall to get to one another. So without even having to do all that calculation, which I did all the calculation there, but without having to do all of that, x squared minus x minus 1. You'll notice that if I'm looking for the points at 2 and 3, I'm going to pull the table up for this because it might make it easier to see it. We can see that from 2 to 3, there's an increase for sure, right? It changes from 1 to 5 when you go from 2 to 3. So increase of 4. That's where we got our rate of change of 4. If we look at that next interval, from negative 3 to negative 2, well, negative 2 is up here. Let's look at negative 3. Change that to a negative 3. Again, we can see that a change happens. It goes from 5 to 11 over that interval. So that doesn't work to give a rate of change of 0 either. But if you look at the next one, and they ask us to look at negative 1 to 2. So we'll change this back to negative 1. So if they ask us to look at what happens when you change from negative 1 to 2, it stays 1. It doesn't go up or down. It stays the same. It stays constant. That's where we can see our rate of change of 0. So without even having to do all the rate of change calculation, we can come up with an answer to that just by looking at how the change actually happens. It doesn't change, so it has a rate of change of 0. Just an option for you there, if you didn't want to have to do all these slope formulas over and over and over again. All right, let's keep going. Now I've got 4 questions in here that are test prep style questions. So this looks like what you might see on your state test on these topics. So if you'll take just a minute, pause the video and work through all 4 of them, and then come back and see if you were correct on those answers there. All right, take a look at these now. For that first one, you should have gotten negative 12 as your average rate of change. And I've shown how I set that up here. So I found the values for both interval points. And then I used slope formula to calculate that. And I got negative 12. This one asked you which of these functions was odd. The first one is odd because it has origin symmetry. Flips across the origin to recreate it. This one would have been even because what's here is the same as over here. And what's down here is the same as over here. And then these have neither. But this was your one that was odd. This one asked you the value of the x value when the function's value was negative 4. So I looked where y was negative 4, found my point, and found that the value was 1. And then this one asked you if you had this function and it showed the height of an object after t seconds, how long would it take before the object hits the ground? Well, I know if the object is on the ground that its height is 0. So I was looking for the place where height would be 0. And so you could graph that in Desmos. You actually find 2 solutions, but one of them is negative, so that doesn't make any sense. So my correct solution here was 1.84 seconds. All right, that's the end of those notes. So if y'all make sure you submit them, and have a great day. Thank you.